Back and relook. We had 14 through 20, so let's pick like two of them because, like I said, what we're doing today is going to build right out of it. So
16.
I'll start at 19.
Wow, really?
There you go.
I get confused where the lines crossed.
You just got to be careful in how you set it through. If you space it out a little bit better, it's a little bit cleaner. So we start out this one with the constraints of x is greater than or equal to 0, 2x plus 3y is greater than, whatever, you have it all written down. X is greater than or equal to 0 means it's going to be a quadrant 1, quadrant 4 problem, right off the bat. I know that has to happen. From here, I just start going through intercepts. Well, I'll draw this out. Y-intercept of 2, x-intercept of 3. 0, 2, 3, 0. Nectum is 0 small or 0 bigger than 6.
No.
Nope. Moving outward. Now I do know that this is going to continue here this way because I know that's still there. The next one I have a y-intercept of negative 4.5, x-intercept of 3. So we'll say negative 4.5 is here. X-intercept of 3, so it's going this way. Is 0 minus 0 smaller than 9? Yes. So it's going inward, but the overlap starts to occur out here. Okay? So right now I know that I'm, from just this part here, I'm bound up between those for right now. Yeah. And last but not least, x-intercept of 20, y-intercept of 4. Is 0 plus 0 smaller than 1? Yes, so it's coming inward again. So you wind up with this region here.
Wait, how did you do for the x minus 2y again?
I got the y-intercept at negative 4.5.
Okay.
I got the x-intercept at 3.
Okay.
So I was coming up this way. The 0 and minus 0 is smaller than that, so it came inward.
Okay.
Okay.
I got it.
So now, the only one we have to look at as far as our intersection is this point right here. We have the other 3 ordered pairs. That point right there is the intersection between those two. Bless you. That's setting you up right away to do a system of equations via substitution. Everybody see that?
Yeah.
It sets you up to go to substitution, whereas x is going to equal 20 minus 5y. It does. It really doesn't. I just saw that I had a single one there. There's many ways to set them through. So substitute in 3 times the quantity, 20 minus 5y minus 2y is 9. 60 minus 15 minus 2y, 9. Negative 17y is negative 51. I believe that's 3.
Yeah.
So if y is 3, I go back to here. 20 minus 15 is? Very good. So my ordered pair here is at 5 and 3. Now I have my values to check in my objective function. My objective function was 4x and 3y. And I just go through the ordered pairs. It's got, what was it, 0, 2, 3, 0, 5 and 3, and 0, 4. So 4 times 0, 3 times 2, 4 times 3, 3 times 0, 4 times 5, 3 times 3, and 4 times 0, and 3 times 4. 6, 12, 29, and 12. Minimum, maximum. Okay. What was the other one you looked at?
16.
16? I think, did 16 have the weird fraction also, I think? Or was this the only one that had a fraction?
16, like, I didn't know what to do, because, like, you just shade opposite.
Okay.
Can we go back to the other one real quick? Just like a few seconds. Mr. Murphy?
Yo.
Can you go back really quick, just like 2 seconds?
At least on 16, you know right off the bat that it's only one quadrant you have to worry about. So you got that going for you, which is nice.
Yeah.
Okay. We go to this yet?
Yeah, thank you.
I know we have only a one quadrant problem because of my first two constraints. Thank you very much, Mr. Tuna. I really appreciate it. Ladies and gentlemen, Mr. Tuna.
Hello.
I get paid. Nobody's smiling when I say I get paid. To see me, you gotta, yeah.
Yes, yes they are.
All right.
Thank you, buddy.
Thank you.
All right. All right. We know it's the first quadrant problem. The first one has x and y intercepts at 7, so that's not bad. Hey, if you got that far, you're like 3/4 of the way done.
Yep, that's on.
All right, well, let's see. The next one, the x-intercept would be at 4, and the y-intercept would be at 10. Oh, I forgot the shade. Sorry, I'll do that in a second. So the first one I have to go back and shade. Is 0 plus 0 bigger than 7?
No.
Nope, so it's going outward. Is 0 plus 0 bigger than 20? It's also going outward, which means that if you look at your shade line, here to here, and you have 1 point.
Oh, didn't know that.
Is there a maximum to that? Correct. There's no maximum. There's no maximum to this because there's no lid on it. There's no upper boundary stopping it. So you should be able to notice that right away. This problem will have no maximum. As you go through your, it should have a minimum. As you go through the other one, it might be pretty easy just to do multiply the top one by 2. You get 2x plus 2y is 14. Subtract out, you get 3x is 6, so x is 2.
Yep.
Y is 5.
Sure.
Yep.
Yeah. Yeah. I don't know how many.
So you have, yes ma'am. Technically, there is no maximum, because if you say it's infinite, that just means there's some quantifiable-ish thing. I would say no maximum. Sir?
How do you get that ordered pair? Like, how do you get 2x?
Oh, he just times
I
it
took the
two.
top equation, multiplied it by 2, so I can eliminate the y's. I just
Gotcha.
thought it'd be really fast instead of doing substitution. I saw that and I'm like, oh, that's really quick.
No, they got
Okay. So then you've got your 3 ordered pairs. You check it at 0, 10, 2 and 5, 7 and 0, with negative 2x. So it'd be negative 2 times 0 plus 10, negative 2 times 2 plus 5, negative 2 times 7 plus 0. We have 10, 1, and negative 14. Bless you. So we have the minimum, therefore, at 7, 0.
Oh, sweet. I still have the
It's
number.
exciting.
Oh, yeah.
Hi, how are you? I thought you wanted an AirPod, right? Yeah.
No, but how do you know which points?
No.
How do you know which points like you have to test?
The points that you're always going to test are the ones that have some change of direction. See how it's bound here, here, and here? Where your shading is occurring, since you have this boundary placed on the shading from everything greater than x everything's greater than y. And as we shaded everything else out, you get this boundary line. Those boundary points is where the lines themselves change direction. That's the point at which there's something happening. Those are the points, the intersection spot is what you check for any of these. Okay. That's all it is.
Why doesn't
Is 0, 0 part
you?
of,
No, not 0, 0, 0,
notice, when you had the shade earlier, we had, this was shaded going outward here, but it didn't also include this part from the other line, did it? It has to be over it. Remember when you did number line problems, and you had two values, 4 and 6, and they're both going this way? The true overlap didn't occur until after it got out there. It's the same idea. It's the exact same idea as opposed to single variable is two variable. Does that make more sense?
I did some of them.
Yeah, this guy, remember this.
I didn't remember.
I'm an idiot. It's okay. I'll do it. All right. Hold this. Let's do linear programming. The actual kit caboodle of the word problems.
Wait, mister.
I want to talk about how we can construct our own constraint. Yes, ma'am. Yes, I will. Just remind me in like 2 minutes. I want to walk you through the setup of this first. What I have done since I just printed a copy of the word problem so you don't have to try and write it out. This is pain. Yes, ma'am.
I had this from the other day, but I remember it came in complex since I didn't understand it.
Yeah. I'll grab it from you in a second, okay?
No. And I'm coming in again today, so I'm sorry, but
No worries. So what I want to do is I want to walk you through how we can take a very simple word problem that is a constraint problem to maximize some function. And I'm going to start this with the fundraiser one. Okay?
this is where we put this in real life problem.
Yeah. So this is the fundraiser problem. It's number 8, thanks, sir. So if we just read it carefully, just to get the gist of what's going on. Your club plans to raise money by selling 2 sizes of fruit baskets. The plan is to buy a small basket for $10 and then sell it for 16. Buy large baskets for 15 and sell them for 25. The club president estimates that you will not sell more than 100 total baskets. Your club can afford to spend up to $1,200 to buy them. Find the number of small and large fruit baskets you should buy in order to maximize profit. So when you read that, what is the objective of the problem? Make the money, maximize the profit. So you're right, you're using letter C. What I'm going to do here is, as I'm going through this part right here, your objective, they ask you what should you do in order to maximize profit. That is your goal, to find the most money you can get. So now once I've decided that, I need to figure out, well, I've got 2 different types of baskets, small and large. So I'm going to come up with 2 variables, S and L, small and large. SMRT. So I'm going to use small plus, I always use a cursive L, I don't know why.
Yeah.
Now think about profit. We're going to maximize the profit. So how much are they? They make their profit. I mean, you're right. It's 6 and 10 for your profit there. Everybody see how they're getting that?
No.
Yeah.
You're buying it for 10, but you're selling it for 16. So how much do you make on every small basket? $6. And how much are you making on the other ones? 10. So what we've done here is we've figured out that for every small basket that I sell, I make $6. Plus whatever large basket I sell, I'm going to make $10. The combination of the greatest number of small and large baskets will give me the most profit. Does that make sense?
Yes.
Okay. Go back and start thinking. Can I ever sell a negative amount of small baskets?
No.
So I'm going to be bound by that. Same thing with large baskets. It has to be greater than or equal to 0. I could sell no small baskets, or I could sell no large baskets. But I can never sell negative amounts. You see how, like we were talking yesterday, how a lot of these things work out to be first quadrant?
Yeah.
It's the same idea. The next bit on there, it said the club president estimated that you won't sell more than 100 total baskets. So that means there's some combination of small plus large has to be. Now let me ask you this: small plus large, less than 100. Can you sell 100? So is it going to be just less than or less than or equal to? Good. See how easy it is to pull that out of there? And what's the last bit of information I'm talking about? Can you spend 1,200?
Yeah.
So you can spend up to and including 1,200. So you can still spend $1,200. How much does a small basket cost you?
6.
That was profit.
10.
It was $10, and then the large was 15. So it was 6 for the small, plus 15 for the large.
16.
Wait, why did I become
16.
15?
Oh, was it?
You buy it.
Oh, I'm sorry. You're sorry. DJ, is that what you're about to tell me?
15 is right.
10. It was 10 for small. I'm sorry. And I just told you that was
Yeah.
profit. And it was 15 for the large. Okay.
No, 20. So,
No, guys.
Buying.
You're buying them for 10, selling them for 16, so your profit is 6. You're buying them for 15, selling them for 10, so your 10 is your
Oh,
profit.
I see what we did. I see
Okay.
what's
You just said buying for 15, selling them for 10.
Whatever. All right. Now, notice all you have to do is the same thing we did last night. We're going to graph it and find the intersection.
Sweet.
That's like some big points.
So when we graph this, we know it's a first quadrant problem. And I also know that I don't have my axis labeled. Does it matter which one I call small and large? No. It really doesn't. I'm just going to, as long as I label it and keep it consistent, it's fine. It does not matter which axis you put it on. It'll still work. So what is your intercept for your small and what's your intercept for your large? For the first equation.
100.
It's 100. 0, 100, 100, and 0. Which way do you shade? Inward or outward?
Inward.
Inward, very good. So we move inward.
Why are we shooting again?
0.
Okay, I just didn't pay attention. So
Go to the next one. Your S intercept is going to be what now? 120, very good. So it's going to be at 120 for this one, so it's just above it at 0, 120. And then 15 goes into 1200. I think it's 80. Is it 80? You have a calculator.
It is 80.
I have a brain. It is?
Yeah.
Sweet. And lo and behold, look what two things intersect each other. Because what direction am I shading that one? Inward again.
So it's the truth.
So I need to find this intersection point between the two.
Okay.
Okay, I'll find it. Yeah. I'm looking at this one thinking I'm just going to do multiply the top one by 10, and just go 10s plus 10l is 1,000. Subtract it out, I get 5l is 200. L is 40. You okay with that?
What'd you do?
I just did a scalar. I multiplied the top equation by 10, wrote it below it, subtracted them to eliminate s. So I solved for L.
Okay.
And now, what plus 40 is 100?
660.
There you go. So this intersection point is at 40. Because remember, that was L, so we have to make sure we put that first. That's where the trickiness comes in. You might forget which way you labeled your problem. So just make sure wherever you put L is the first coordinate or the second if it's on the other axis. So your test points to check for maximizing profit are at 0, 100. Now remember, this is S and this is L. 0, 0. Oh, sorry, I had it backwards. L and S. Sorry. 80 and 0, and 40 and 60.
Wait, why do you include
Bravo.
the 0, 0 in this one?
Well, you don't really need to, but it's still one of those points.
Oh, wait, can you 40 and then what was it last one?
It was 40, 60.
Okay.
So if you had your profit function, is this guy. Just bring that down. So that means we can say 6 times 0 plus 10 times 100. No, we know this one's not going to work. 6 times 80 plus 10 times 0. 6 times 40 and 10 times 60.
That one.
So here we have 1,000.
Same.
Yo.
You switched up.
How'd you get that actually? Because if
I have L's on this side, S is here.
But you have 100, where the 6 times 0 should be, it should be 6 times 100 and 10 times 0.
Thank you. Thanks, DJ. I didn't catch that. What DJ just picked up on there? Look at my profit function, my overall objective function. It's 6 times the S, 10 times the L. I had listed out L's first. I just missed that.
Oh.
Okay? Now, here's the deal. Let's say you did that, and you just flip-flopped anything. You did everything correct, but you just flip-flopped an ordered pair. Am I going to be horribly mad at you?
Yes.
No. You did it. You just made a stupid mistake at the very end. Like I did. And I'm not going to say, you get all these points off. No. You'd be surprised. You understand the concept, I screwed
You're
up.
pretty.
We
You're
gotta
pretty.
switch it up. What you're saying.
Yeah.
Me, not so much.
So it'd be 6 times 100.
So 100 times 0.
Let's see if the continues on here. Wait.
You know, we still know 0, 0 is not going to work, so that's good.
So this is no longer.
Are we testing on Friday?
Yeah.
Kills my phone. I got a lot to understand.
Why is it 100 times?
Did you flip this when you did
I
backwards?
mean, 10 times 0.
Too many zeros. So it's 10
Done.
times 0. This is L.
You get 600 for the first.
So how should it? How did it's the right way?
10, 6 times 60 plus 10 times 40.
Why is it?
So you make 600 on the first one. 800 here. 400 plus. So 360.
760.
So you make 760 here. So if you sell 40 large baskets and 60 small baskets, that's how you would maximize your output and profit.
Wait,
No.
wait, is it 800 bigger than 760?
Oh my god.
Math! I swear to you, I'm not this bad.
Are you sure you're serious?
I'm not too sure.
Well, I can't figure out like with an X and a Y when yesterday. I don't know why.
Why did I screw that? You know why? I bet you because I wrote the S first instead of writing L's.
DJ threw you off.
Yeah. So we'll blame DJ. Let's look at the other one.
Yeah, this is a okay, so wait, Mr. Murphy.
Yes, ma'am.
We found the maximum, but what was that doing? Like, we just like,
Maximize it.
What's that?
that's the maximum one we'll go with?
The other one is another really very simple one. I've actually had to do something like this before when you're trying to figure out like just storage. You have X amount of space and X amount of money. So as you read through the cabinet one, you're purchasing filing cabinets and you want to maximize your storage space. So right there in the first sentence, your objective is to maximize storage. You want to maximize. Oop, that didn't show up very well. We want to maximize storage space. So everywhere in this problem that talks about storage space is what I'm going to use for my objective function. So the office has a total of 60 square feet of floor space for the cabinets and $600 in the budget. So you know right away you have two constraints: money and floor space. Cabinet A needs 3 feet of floor space. It has a storage capacity of 12 cubic feet, and it costs you $75. B is 6 feet of floor space. Storage is of 18 cubic feet and costs $50. How many of each do you get? So we're looking to maximize our storage. I'm going to look in here. I knew that there's a cabinet A and there's a cabinet B. How much storage capacity, according to the problem, was A?
3.
That's 3 feet of storage space, but it has a storage capacity of 12 cubic feet. So A has 12 cubic feet. B is 18. Very good. So we start. Can you have negative cabinets?
No.
So you know it's a first quadrant problem. You had the first constraint they discussed was floor space, the 60 square feet. So I know it's got to be up to and including 60 square feet. So I can use all of the floor space, or I can use less than. Does that make sense?
Yes.
Pretty much all of these are going to be a less than or equal to or greater than or equal to. You're never going to, I don't think I've ever seen one that's just a less than symbol. It's very, very rare. So on cabinet A was what? 3? And how much was with B? 6. The next one you had money. You have up to $600 to spend.
Oh, we do. Great.
And
75 and 50 respectively, I believe.
yeah.
Okay. So now you have everything you need to do.
First quadrant.
It's a first quadrant problem. So I don't screw this up again. I'm going to put A on the bottom because it comes first in the alphabet. DJ's shaking his head. Yes, you should. That's fine. If you want to change next one, it's not a big deal. Whatever. Okay. Intercepts. B intercept of. A intercept of.
20.
Excellent.
B.
20. Here's 10. Inward or outward? Inward. It's moving towards 0. Let's see. B-intercept of that is going to be what? 115? No. 12.
12.
Yeah. It's 12, correct?
Yeah, it is.
So B-intercept is...
What's so funny about that?
I don't know. It's 12. A is 6.
8.
8.
That was close. Oh yeah, 6 would have been 300, double it would be 8. And it's moving inward again. I need to find the intersection here. Couple of ways of going about it. You can multiply the top one by 25.
That's right. It is.
Subtract it through. You could use substitution because you can take the top equation, divide everything by 3 if you want. There's a bunch of different ways.
I
Yes.
forget when you add and when you subtract.
You always subtract when you have the same sign, the same coefficient.
So subtract.
If they're all the same.
Okay.
You add if they're the same coefficient with opposite signs.
All right.
So how do you guys want to do that one? Yes, sir.
How did you get the bottom equation? Like you got like 75
That was the cost one. We have up to and including $600 to spend. You have each cabinet of A is $75 and the other one is up to.
150.
So let's see. Or if you divide this one by 25.
Yeah, that's what I'm doing.
Why don't we just do the 3A plus 6B?
Whatever. What do you guys get?
Divide by 3.
What's that?
I'm not necessarily.
I'll just do the bottom one by 25. It's just as fast. So we have 3A, 6B, 60, 3A, 2B. What is that? How many quarters are $1.04? Is 24?
Yep.
He does weird math. He does quarters.
Chill.
How many quarters are in $1?
4.
I
Four
got it.
of them. This is $6.
2.
I'm gonna get it, so it's okay.
I'm confused.
I don't get it either. Sorry.
Do you have a calculator? There's buttons.
Yeah.
You can verify. Is 600 divided by 20?
Yes, it is.
4B.
Oh,
I like
two. No need for the 2.
The 2.
Yes.
Yes, Matt! Woo!
I swear.
I think I did it wrong.
I was looking down. I got 21.
Oh man.
I got
9.
I got a 9 too.
I got 2 9.
Okay, I'm just saying B is 9. Is all I'm saying.
Oh,
All right. I don't know what the other one is yet.
Oh,
I don't know.
I read that wrong.
We put
I
9
thought
down
that's
in
a
the
19.
So,
Yeah.
No, we're cool. We're cool.
all right. Whew. Made me nervous here. So, yeah, if I go back into here, it's 54, 6. 3 times 2 is 6, so 2 and 9.
I thought it said 19.
Okay. So all we have to do now is test it. Do I need to worry about testing maximum stuff at 0, 0?
No.
And you're going to be able to realize that there's some points you don't need to test because it doesn't make any sense. So if I'm going A, B, for my ordered pairs, I have 0, 10, 2, 9, 8, 0.
What is it? Equals 2. That's what I got.
So 12 times 0 plus 18 times 10. 12 times 2, 18 times 9. And 12 times 8,
Wow.
Yeah.
18 times 0.
Not that behind. Just working fast. Did you use 0, 0 as a point? No, just 3.
I know that's not going to maximize anything because if I don't buy any cabinets, I can't store anything.
Okay.
0.
So it's just like the 3 that are actually.
Yeah, it depends on how many constraints you wind up with. I think more often than not, you wind up first quadrant with at least 2
You see that?
equations because that way you can find some intersection.
Okay.
From time to time, you might have like an extra parameter thrown in just to mess with you. But I think for today, we're just going to keep it at the 2 parameter ones. So the first one is what, 180?
Yeah.
Right? Or
Because you do 50 minus 150.
How much is it? 186.
Chill.
And 240?
so 8 and 0 is
Oh wait, yeah. It's 8, that's 9, it takes 8, so yeah,
It's
96.
96.
96. I'm saying, wait no second. Yeah, 8 foot is 96 inches.
I don't know how
Are
you're
we
doing
finding
this.
the maximum?
Yes. Because you're looking.
Wait.
We
That
have,
worked for one.
this would be 180, so this is
Little.
162. 162 and 24 is 186. Yeah. I got 186, 180. So your best bet is to get 2 of one, 9 of the other. That'll give you the most storage. capacity.
Wait, I have to chew them. I gotcha.
Huh.
I like this. These are exciting.
Oh, yeah.
I love these problems.
They take a longer time to do,
It shows you how you can use basically everything we've reviewed over the past couple of weeks, what was leading up to just this one problem.
Yeah, that's
All the inequalities, the systems of equations, how all those things blend together, how do you write out an equation. So what I want you guys to work, guys. What I want you guys to attempt a few of this evening, I want you to try let's see. I'm going to walk you through one more of these. We have time. No, I just stopped. Here's a chunk. I'm going to walk you through. Yes, ma'am. Yes. What I would like you guys to do while I'm passing some of this stuff back is I would like you to try and set up question number 1. So, ladies and gentlemen, come on. I want you to set up your constraints for question number 1. Use a separate sheet of paper. On this sheet,
On the sheet, you want to sort it, or do you want to?
just on like a regular,
Separate sheet?
yeah. So if I'm looking at this one, I'd like you guys to start writing out this.
okay.
I'm going to try and pass back a few of these things real fast because it's just a bunch of old homeworks and stuff. And then if you get, all right, let's roll through it real quick. Come on, guys. I don't have much time left here. So you have business class and tourist class seats for a charter flight. To charter a plane, at least 5 business have to be sold and at least 9 tourist class have to be sold. The plane does not hold more than 30 people. Fly High makes a profit of $40 for each business and $45 for each tourist. In order to maximize profits, how many tourist classes are we going to sell? So we know that our constraint is going to be about profit. So we have business class and tourist class.
Oh, what was that?
Okay, we use B and T. Business, you made $40.
Yeah.
Tourist, you got 45. Go through the rest of it. It said that the plane can't hold more than 30 people. So what's the maximum amount you can have?
30.
30. So if you have 30, can you have up to 30?
Yes.
Can you include 30?
Yes.
Okay. So B plus T has to be less than or equal to 30. Pretty straightforward.
Yeah.
Is that all it is just B plus T?
Yes, sir. Okay.
New.
After that one, you had what? The plane, you must have at least 9 tourist class. So tourist class had to be at least 9. So what would that look like?
Greater than or equal to
Good.
3.
Greater than or equal to 9. And the other one has to be
5, so it's 3.
Now this one is going to be really nice and easy. You've got two vertical lines going up to a diagonal parameter. You should be able to figure that one out relatively simple. I hope. I know we're running really short on time. Can you have negative seats?
No.
So it is a first quadrant problem, obviously. Make sure you try and set them up best you can. Your best bet for these things is to just start with your maximize, what you're trying to maximize or what your objective is, and then work off of that. Try the first 4. Last one on there is tough. Try and solve them out too, okay? Set them up and solve them. All right? Thank you guys. We'll see you tomorrow.
Wait, so